So in this new session we are going to start a new chapter of plus one chemistry, that is hydrogen. So without wasting any time, let us move towards the chapter. So now on the screen you can see hydrogen. So first of all, let us have some brief introduction about hydrogen. So hydrogen is the most abundant element in the universe. Yes, 74% of universe is comprised of hydrogen, and it has simplest atomic structure. Yes, since hydrogen is the first element in the periodic table, it has atomic number 1 and electronic configuration 1s1. This is the simplest configuration, or this is the simplest atomic structure of all the elements in the periodic table. Then it was discovered by Henry Cavendish. How he discovered? He treated iron with sulfuric acid, dilute sulfuric acid. Then there was an evolution of gas. So that gas actually inflammable in nature. Inflammable means combustible in nature. What do you mean by combustible? Any substance which catches fire. You might have observed on the petrol tankers. There they have written like this, inflammable in nature, isn't it? Inflammable means any substance which catches fire or which is capable of catching fire. Inflammable or combustible, both are same. So that gas was actually combustible in nature or inflammable in nature. That's why Henry Cavendish named that gas as inflammable air. But after some years, Lavoisier named scientist named it as hydrogen. Okay, so this is how hydrogen name was generated. So now let us discuss position of hydrogen in the periodic table. You can imagine periodic table like this. So this is S block, this is D block, this is P block, this is F block, and this is noble gas, isn't it? Noble gases. So here hydrogen will be placed here. Hydrogen is somewhere here, isn't it? First position. So this is the position of hydrogen. Why they have kept hydrogen in this position? According to modern periodic law, all the elements present in the group will have same electronic configuration, isn't it? See, the electronic configuration of hydrogen will be 1s1, outermost electronic configuration. Then next element is lithium. Electronic configuration of lithium is 2s1, outermost electronic configuration I am writing. Okay, and next element is sodium. Electronic configuration of sodium is 3s1. So in this way you will get the outermost electronic configuration same for all the elements in the same groups. So since hydrogen possesses the electronic configuration similar to group 1 elements or similar to alkali elements, these are known as alkali elements. Second group elements are known as alkaline earth elements or alkaline earth metals, isn't it? So since hydrogen possesses electronic configuration similar to the group 1 metals or similar to the alkali metals, this hydrogen has placed here. Okay, has been placed here. This is the position of hydrogen. Then hydrogen is also called as rogue element. Why they call hydrogen as rogue element? See, hydrogen, as per the periodic law, hydrogen should show the properties similar to group 1 elements, isn't it? But hydrogen also shows characteristics similar to group 17 elements. Which are group 17 elements? Halogens. Halogens are nothing but fluorine, chlorine, bromine, iodine. So hydrogen shows properties similar to alkali metals. Along with that, hydrogen also shows some chemical properties which are similar to group 17 elements. Since hydrogen shows different behaviors, this is known as rogue element. Okay. Then moving on to next slide, isotopes of hydrogen. So what is isotope? First, have an idea about isotope. We can represent any element like this, AX, Z. So this is the name of the element, this is the mass number, this is the atomic number. So if any element possesses different mass number but same atomic number, then such elements are known as isotopes. So for example, hydrogen has 3 isotopes. One is protium, second one is deuterium, third one is tritium. you can see the elemental form here. So here you can observe the mass number is undergoing change. See, in case of protium, mass number is 1, deuterium mass number is 2, and tritium mass number is 3. And we have same atomic number 1, 1, 1. Okay, so I think you know what is atomic number is nothing but, what is atomic number is nothing but number of protons or number of electrons. In each hydrogen, number of protons remains same. Okay, 1, 1, 1. Or number of electrons remains same, 1, 1, 1. Then what is mass number then? Nothing but number of protons plus number of neutrons which are present inside the nucleus. You can see the nucleus of hydrogen. In the first hydrogen, that is in case of protium, there is no neutron. So that is the reason why it possesses only one mass number. But in the deuterium, you can see one neutron. So mass number changes to 1 plus 1, 2. So that's why they have written 2. So in tritium, you can notice another one neutron extra. So 1 plus 1 plus 1. So totally we have mass number 3. So 3. So this is isotopes of hydrogen. Okay. Now, what are the relative abundance? Relative abundance means out of these three isotopes, protium, deuterium, tritium, which amongst them exist in large quantities? That is protium. So in universe, we will get protium as a major element. Okay. Then at second position we have tritium, and third position we have deuterium. So this column not required to you. Now let us move towards preparation of dihydrogen. So hydrogen can be prepared by various methods. So in order to simplify, we will subcategorize those two into two. Like we can prepare hydrogen in lab, we can prepare hydrogen in commercial scale. So hydrogen can be prepared inside the laboratory itself, but in small quantities. So we can prepare hydrogen in laboratory in small quantities only. We can't produce hydrogen in bulk quantities. But if we can also prepare hydrogen in commercial scale. Commercial scale means bulk scale or bulk quantity. We can produce enormous amount of hydrogen for industrial purposes. Okay. So first we will start with how can we prepare dihydrogen in small quantities, that too in laboratory. So first method, by the reaction of granulated zinc with sulfuric acid or with aqueous alkali. Yes, aqueous alkali means nothing but base, any base. Okay, so we have to take granulated zinc, we have to treat that with sulfuric acid. Then you will get hydrogen gas, evolution of hydrogen gas. This gas is collected over tanker. Okay, so this is how we manufacture hydrogen. You can also prepare dihydrogen by treating granulated zinc with alkali or aqueous alkali or base, that is NaOH. So you will get hydrogen gas once again. This is sodium zincate. Sodium zincate. Sodium zincate. So what do you mean by granulated zinc? Granulated zinc are nothing but powdered zinc. Okay, you remember like that. Powdered zinc. Card tara irutte, crystals tara irutte. That is known as granulated zinc. Now the second method, we can produce dihydrogen in commercial scale, in larger scale. So that is first method, we can produce hydrogen in commercial scale. It's nothing but electrolysis of acidified water. So by electrolysis of acidified water, we can produce dihydrogen in large quantities. How? See, first of all, understand what do you mean by electrolysis. So in this context, I am going to give you a simple introduction. I am not going in deep, okay, because you will study electrolysis, electrochemical cell, electrolytic cell, everything in second years in +2. Okay, we have separate chapter for that, that is electrochemistry. There you will study, but in this context we will discuss lightly. Okay, so electrolysis of acidified water means passing electric current to acidified water. So when you pass electric current to acidified water, that will release hydrogen gas. So that is the principle. Okay. So in order to pass the current, we need terminals, isn't it? We need positive terminal, we need negative terminal. So from that we can produce what? We can pass current. So that one we will discuss now. See, this is a cell. Imagine this is a cell. So here we will be having water. This is water, acidified water. Acidified water means water with small amount of acid. Okay, acidified water. Here we will be having a positive terminal, here we will be having negative terminal. In any cell we will call positive terminal as anode, negative terminal as cathode. You have to remember that. Okay, generally here the positive terminal or negative terminal is made up of platinum, okay, or graphite, but in this case you can remember only platinum. Okay, because NCERT has mentioned platinum, so we will remember platinum only. Okay, so we will use platinum material as cathode and anode. Okay, so then these electrodes are connected to battery, external battery, so where we will pass current. So when we pass current through this battery, current will flow here, isn't it? So due to the movement of current inside the water will get ionized to give H plus and OH minus. That is known as ionization. Now at anode what happens? Oxidation. At cathode always there will be reduction. So at anode what happens means, since we obtained OH minus through the ionization process, these OH minus will undergo oxidation to give OH. See how, as you know that from redox reactions we studied, what do you mean by oxidation? Loss of electrons or nothing but oxidation, or decrease in the oxidation state is also called as oxidation. So in this reaction you can observe OH minus is losing electrons to give OH. That is oxidation. Or in terms of another definition, OH minus 1 is losing, or it is undergoing decrease in the oxidation state, isn't it? So this is how we can get what? Oxidation process. So these OH minus will further combine themselves, tamak tave combine agi, that will form water once again. Okay, so this is the oxidation reaction occurs. So you have to remember this first step, very much important. From this step we can understand oxidation of OH minus to give electrons. Then once electrons are produced at anode, when many number of electrons are produced at anode, these electrons will move towards cathode, negative electrode. Okay, towards negative electrode. So at cathode these electrons will react with H plus ions. Where were H plus ions? We obtained those H plus ions through ionization, isn't it? So those electrons will react with H plus ion to give hydrogen. Okay, to give hydrogen. So those number of hydrogens, so you will get n number of hydrogens. Those n number of hydrogens combine themselves to give hydrogen gas. So you will get hydrogen gas at cathode. Since hydrogen gas is lighter in nature, that will move up and we can collect that hydrogen gas separately. So this is how electrolysis of acidified water is made. Okay, so electrolysis of acidified water means passing electric current to acidified water. So in order to pass electric current to acidified water, we want an instrumental setup. ನಮಗೆ ಒಂದು ಸೆಟಪ್ ಬೇಕು. ಸೊ ಸೆಟಪ್ ಈ ರೀತಿ ಇದೆ. ಸೊ ಇಲ್ಲಿ ವಾಟರ್ ಇದೆ, ಅಸಿಡಿಫೈಡ್ ವಾಟರ್. ಸೊ ಎಕ್ಸ್ಟರ್ನಲ್ ಬ್ಯಾಟ್ರಿ ಕನೆಕ್ಟ್ ಮಾಡಿದ್ದೀವಿ. ಸೊ ಕರೆಂಟನ್ನು ಪಾಸ್ ಮಾಡೋದಕ್ಕೆ ವಿ ನೀಡ್ ಎಲೆಕ್ಟ್ರೋಡ್ಸ್. One is positive electrode, another one is negative electrode. In case of electrolytic cell, we call positive electrode as anode, negative electrode as cathode. Those two are made up of platinum material, isn't it? So when we pass the electric current, water undergoes ionization to give H plus and OH minus ions. So first at anode, these OH minus ion undergoes reduction to give undergoes oxidation to give electrons, and those electrons are moved towards cathode. And at cathode reduction occurs, electron reacts with H plus ions, isn't it, to give hydrogen. So those hydrogen combine themselves to produce hydrogen gas. Since hydrogen gas is lighter in nature, we can get hydrogen outside the container, isn't it? So this is about electrolysis of water. So this is the commercial scale of production. This is a commercial production of hydrogen where we can produce enormous amount of dihydrogen for industrial scale. Then the second commercial production of hydrogen method is this one. Okay, we can get high purity dihydrogen, that is about 99.95% dihydrogen, by electrolyzing warm aqueous barium hydroxide solution. Okay, barium hydroxide, BaOH twice. So when you pass electric current to barium hydroxide solution, you will get high pure dihydrogen gas. Okay, so just you remember last method. How can we electrolyze barium hydroxide? You have to take barium hydroxide. Okay, you have to take barium hydroxide. You have to take two electrodes. One will be anode and one will be of cathode, isn't it? So one will be of cathode and another will be of anode. So when you pass current through the external source, electrolysis occurs, ionization occurs, then there will be production of what? Hydrogen gas at cathode. Okay, but actually these diagrams and all not there in your syllabus, so no need to remember. Just you remember electrolysis of barium hydroxide solution use high pure hydrogen. Okay, then where we use high pure hydrogen? Do you have any idea? We use high pure hydrogen in case of what? Fuel. Okay, rocket fuels. So rocket fuel uses high pure dihydrogen. Okay, now third method, how can we produce dihydrogen, is by partial oxidation of hydrocarbons. Okay, you know what are hydrocarbons? Hydrocarbons are nothing but organic compounds contains only carbon and hydrogen. What is oxidation? Addition of oxygen. What is partial oxidation? We are not adding pure oxygen, instead we are acting some amount of oxygen through water molecule. So we will not react hydrocarbons with oxygen, instead we are treating hydrocarbons with water. So if we treat hydrocarbons with water, that is known as partial oxidation. ಯಾಕೆ ಅಂದರೆ ಆಕ್ಸಿಜನ್ ಹಾಕಿದ್ರೆ ಕಂಪ್ಲೀಟ್ ಆಕ್ಸಿಡೇಷನ್ ಆಗುತ್ತೆ. ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ದಟ್ ಆಕ್ಸಿಜನ್ ಇರುವಂಥ ಕಾಂಪೌಂಡ್ ಲೈಕ್ ವಾಟರ್ ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಿದ್ರೆ ನಮಗೆ ಅಲ್ಪ ಸ್ವಲ್ಪ ಆಕ್ಸಿಡೇಷನ್ ಆಗುತ್ತೆ. ದಟ್ಸ್ ವೈ this is known as partial oxidation. Okay, so you take any hydrocarbon, you treat that with steam means vapor state water. Okay, in the presence of nickel chromium catalyst at 1270 Kelvin temperature, you will get hydrogen gas. Okay, so what is the purpose of adding catalyst here? See, catalyst will increase rate of reaction. Catalyst will increase rate of reaction or speed of reaction. So catalyst ಅನ್ನು ಹಾಕಿದ್ರೆ reaction speed ತುಂಬಾ fast ಆಗುತ್ತೆ. That's why we will add catalyst. So in this through this method we can prepare hydrogen. But hydrogen ನಿಮಗೆ separate ಆಗಿ ಸಿಗೋದಿಲ್ಲ ಇಲ್ಲಿ. You will get hydrogen with carbon monoxide. So ಇಲ್ಲಿ ಏನು ಮಾಡಬೇಕಂದ್ರೆ ನೀವು hydrogen ಅನ್ನು separate ಮಾಡ್ಕೋಬೇಕಾಗುತ್ತೆ. Then fourth method, we can also prepare dihydrogen through water gas shift reaction. You remember this name, water gas shift reaction. Water gas shift reaction is nothing but, so ನಿಮಗೆ ಲಾಸ್ಟ್ ಮೆಥಡ್ ಅಲ್ಲಿ ಏನು ಬಂದಿದೆ ಪ್ರಾಡಕ್ಟ್, ದಟ್ ಈಸ್ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ಅಂಡ್ ಹೈಡ್ರೋಜನ್ ಮಿಕ್ಸ್ಚರ್. ಸೊ ಇದನ್ನ ವಾಟರ್ ಗ್ಯಾಸ್ ಅಂತ ಕರಿತೀವಿ. 1 ಮಾರ್ಕ್ ಕ್ವಶನ್ ನೆನ್ಪಿಟ್ಕೊಳ್ಳಿ, ಯು ಹ್ಯಾವ್ ಟು ರಿಮೆಂಬರ್ ದಿಸ್. ಸೊ ದಟ್ ವಾಟರ್ ಗ್ಯಾಸ್ ಇಸ್ ಫರ್ದರ್ ಟ್ರೀಟೆಡ್ ವಿತ್ ಸ್ಟೀಮ್ ಆರ್ ಫರ್ದರ್ ಪಾರ್ಷಿಯಲ್ ಆಕ್ಸಿಡೇಷನ್ ಅನ್ನ ಮಾಡ್ತೀವಿ, ಬಟ್ ಇನ್ ದ ಪ್ರೆಸೆನ್ಸ್ ಆಫ್ iron oxide, Fe2O3 catalyst and chromium oxide catalyst. Fe2O3, that is iron oxide catalyst and chromium oxide catalyst. Why we add catalyst? To increase the speed of the reaction at 773 Kelvin temperature. Then we will get carbon monoxide with hydrogen gas. Okay, ಈ ರೀತಿ ಸಿಗುತ್ತೆ ನಮಗೆ. ಸೊ ನಿಮಗೆ ಡೌಟ್ ಬರ್ಬೋದು, ಸೊ ಇಲ್ಲಿ ನಮಗೆ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ಮತ್ತು ಹೈಡ್ರೋಜನ್ ಸಿಕ್ಕಿದೆ, ಮತ್ತೆ ಇದನ್ನು ನಾವು ಯಾಕೆ ಪಾರ್ಷಿಯಲ್ ಆಕ್ಸಿಡೇಷನ್ ಮಾಡಿ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಪ್ಲಸ್ ಹೈಡ್ರೋಜನ್ಗೆ ಆಕ್ಸಿಡೈಸ್ ಮಾಡ್ತೀವಿ? ಸಿ, ಬಿಕಾಸ್ ನೀವು ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ಮತ್ತು ಹೈಡ್ರೋಜನನ್ನು ಸಪ್ರೇಟ್ ಮಾಡೋದಕ್ಕೆ ಕಷ್ಟ. ಓಕೆ, ಬಟ್ ವೆನ್ ಯು ಫರ್ದರ್ ಆಕ್ಸಿಡೈಸ್ ದಿಸ್ ಕಾರ್ಬನ್ ಮೊನಾಕ್ಸೈಡ್ ಟು ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್, ದೆನ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡನ್ನು ನಾವು ಪ್ರೆಷರ್ ಇನ್ಕ್ರೀಸ್ ಮಾಡಿಬಿಟ್ಟು ವಾಟರ್ಲಿ ಡಿಸಾಲ್ವ್ ಮಾಡಿಬಿಡ್ಬೋದು ಈಸಿಯಾಗಿ. ಸೊ ಯು ವಿಲ್ ಗೆಟ್ ಹೈಡ್ರೋಜನ್ ಸಪ್ರೇಟ್ಲಿ. ಸೊ ಹೇಗೆ ಅಂತಂದರೆ, ಸಿ, ಈಗ ನಿಮಗೆ ಒಂದು ಕಂಟೈನರ್ ಇದೆ, ಕಂಟೈನರಲ್ಲಿ ನಿಮಗೆ ಮಿಕ್ಸ್ಚರ್ ಆಫ್ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಮತ್ತು ಹೈಡ್ರೋಜನ್ ಸಿಕ್ಕಿದೆ. ಸೊ ಅಲ್ಲಿಗೆ ನಾವೇನು ಮಾಡ್ತೀವಿ, ವಾಟರ್ನ ಪೋರ್ ಮಾಡ್ತೀವಿ. ವಿ ವಿಲ್ ಪೋರ್ ವಾಟರ್ ಟು ಇಟ್. ಸೊ ಅವಾಗ ಗ್ಯಾಸ್, ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಕೂಡ ಗ್ಯಾಸು, ಹೈಡ್ರೋಜನ್ ಕೂಡ ಗ್ಯಾಸು. ಎಲ್ಲಿ ಬರುತ್ತೆ? ಅದು ಮೇಲೆ ಬರುತ್ತೆ, ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಆ್ಯಂಡ್ ಹೈಡ್ರೋಜನ್. ಬಟ್ ಆ ಕಂಟೈನರ್ಗೆ ನಾವು ಮೇಲ್ಗಡೆಯಿಂದ ಪ್ರೆಷರನ್ನು ಹಾಕಿದಾಗ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಸ್ವಲ್ಪ ಡೆನ್ಸರ್ ಇರೋದ್ರಿಂದ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ ವಾಟ್ರಲ್ಲಿ, ಅಂದರೆ ವಾಟರ್ ಒಳಗಡೆ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ. ಬಟ್ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸು ಲೈಟರ್ ಇನ್ ನೇಚರ್, ಅದು ಡಿಸಾಲ್ವ್ ಆಗೋದಿಲ್ಲ, ಅದು ಮೇಲೇನೆ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಸೊ ಮೇಲೆ ಉಳ್ಕೊಳ್ಳೋದನ್ನು ನಾವು ಈಸಿಯಾಗಿ ಹೊರಗಡೆ ಕಲೆಕ್ಟ್ ಮಾಡ್ಕೋಬೋದು ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸನ್ನು. ಓಕೆ, ವಿ ಕ್ಯಾನ್ ಕಲೆಕ್ಟ್ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಈಸಿಲಿ. ಸೊ ಯು ಕ್ಯಾನ್ ಸಿ second point of note, carbon monoxide removed by dissolving it in water under high pressure, that is 20 to 25 atmosphere. ಸೊ ಹೈಡ್ರೋಜನ್ ಡಿಸಾಲ್ವ್ ಆಗೋದಿಲ್ಲ ಆ ಪ್ರೆಷರಲ್ಲಿ, ಯಾಕೆಂದರೆ ಹೈಡ್ರೋಜನ್ ತುಂಬ ಲೈಟರ್ ಇನ್ ನೇಚರ್. ಸೊ ವಾಟರಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಆಗೋದಿಲ್ಲ ಈಸಿಯಾಗಿ ಅದು. ಸೊ ಅದನ್ನ ಏನು ಮಾಡ್ತೀವಿ, ಮೇಲ್ಗಡೆ ಇರುತ್ತೆ, ಅದನ್ನು ಕಲೆಕ್ಟ್ ಮಾಡ್ಕೊಳ್ತೀವಿ. ದೆನ್ ನೋಟ್ ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ನೋಡಿ, ದಟ್ ಈಸ್ ವಾಟರ್ ಗ್ಯಾಸ್ ಈಸ್ ಆಲ್ಸೋ ಕಾಲ್ಡ್ ಎಸ್ ಸಿಂಥೆಟಿಕ್ ಗ್ಯಾಸ್ ಆರ್ ಸಿನ್ ಗ್ಯಾಸ್. ಯಾಕೆ ಅಂದರೆ ಈ ವಾಟರ್ ಗ್ಯಾಸನ್ನು ನಾವು ವಿ ವಿಲ್ ಯೂಸ್ ವಾಟರ್ ಗ್ಯಾಸ್ ಇನ್ ದಿ ಪ್ರೊಡಕ್ಷನ್ ಆಫ್ methanol, or in the synthesis of in the synthesis of methanol, or in the manufacturing of methanol. Okay, so synthesis, manufacturing, production ಅಂದ್ರೆ ಎಲ್ಲ ಒಂದೇನೆ. ಓಕೆ, ಸೊ ವಾಟರ್ ಗ್ಯಾಸನ್ನು ನಾವು ಮೆಥನಾಲ್ ಪ್ರೊಡ್ಯೂಸ್ ಮಾಡೋದಕ್ಕೆ ಮತ್ತು ಹೈಡ್ರೋಕಾರ್ಬನ್ಸನ್ನು ಸಿಂಥಸಿಸ್ ಮಾಡೋದಕ್ಕೆ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅದಕ್ಕೆ ವಾಟರ್ ಗ್ಯಾಸನ್ನು ವಿ ಕಾಲ್ ಸಿಂಥೆಟಿಕ್ ಗ್ಯಾಸ್ ಆರ್ ಸಿನ್ ಗ್ಯಾಸ್. ದೆನ್ another one simple note, what do you mean by coal gasification? These are all extra things to you. Okay, coal gasification means production of syn gas from coal. Yes, we can produce syn gas, that is carbon monoxide and hydrogen from coal. Okay, no need to study reactions and all that, those are not there in your syllabus. Just to remember, we can produce syn gas from coal. That production of syn gas from coal is known as coal gasification. The next is, this is one of the important method. Okay, wait a minute. We can also produce hydrogen commercially through this method, that is electrolysis of Brin solution. So when you electrolyze Brin solution, you will get what? Hydrogen gas. How? I think in lower classes you might have heard about this Brin solution. What do you mean by Brin solution? Sodium chloride solution. Okay, Brin solution is nothing but sodium chloride dissolved in water. Okay, this is the Brin solution. When you electrolyze this, how to electrolyze? By passing electric current. How can you pass electric current? You have to take anode, you have to take cathode, isn't it? Like this. You have to take cathode, you have to take anode. Okay, you have to pass electric current to it. And here we have taken two electrodes. Okay, this is one electrode and this is another electrode. So one thing, they have written negative here, so I will change. So here they have negative electrode, I will write negative. Here they have taken positive electrode, that means this is anode, this is cathode. Just to remember this. Okay, here anode positively charged, cathode negatively charged. Okay, so we will connect those electrode to external battery and we will pass current. So current flows like this. So when current flows like this, you will get hydrogen gas at cathode. That's all. So how you will get hydrogen gas at cathode? Here you will get bubbles of hydrogen. We will collect that hydrogen to separate container. So first let us see how the electrolysis works. First, Brin solution is nothing but mixture of sodium chloride with water. So when this sodium chloride reacts with water, you will get ions, sodium ions and chloride ions, and you will get OH minus, H plus ions, isn't it? You split all these, you will get sodium ions and chloride ions. Now what happens at anode? At anode there will be oxidation, at cathode there will be reduction. So at anode, these chloride ions present in the Brin solution will undergo oxidation by losing electrons. Okay, by losing electrons. Chlorine, that is Cl minus, undergoes oxidation, that means becomes Cl2 by losing electrons. So these electrons are produced at anode. Here there will be production of electrons. These electrons will move towards cathode, and these electrons reacts with water at cathode. Okay, there will be water molecules, isn't it? So these electrons will react with that water to produce hydrogen gas. That means hydrogen undergoes reduction here. Okay, so this is how hydrogen gas is liberated at cathode. So you will collect that you will collect that hydrogen gas. So overall reaction they have written like this. So Na plus Cl minus and water. Na plus Cl minus is nothing but Brin solution plus water. So you will get chlorine gas, you will get hydrogen gas, you will get sodium ion, you will get OH minus ion. So you will get hydrogen gas at cathode, isn't it? You will get sodium ions inside a solution. You will get OH minus ion inside a solution itself. You will get chlorine gas at anode. Okay, chlorine gas at anode, isn't it? So this is how you can remember this. You will get chlorine gas at anode, you will get hydrogen gas at cathode, you will get Na plus and OH minus ions inside the solution. Okay, so this is the another very good method to produce what dihydrogen commercially. So by the next session we will discuss properties of hydrogen. Till that you watch this video, and one thing you have to suggest some feedback to us, okay, so that we can improve ourselves. So watch this video and make a note of it. Okay, if you are getting any doubts regarding this, please come to me and ask.